Hello everyone, my name is Allison Casey from Period 1 Physics 300, and today we will be reviewing the velocity squared times position graph. It happens to be one of the most complex graphs that I've ever had to solve. So if you can tell just by the line that's shown, we can see that this graph is linear, despite it looking a little wavy in all sorts. So since it's linear, we have to use the famous math equation, y equals mx plus b. And that does not look like a t. So anyways, if you take a look at the chart, you can see that the slope is 1.306, but just for safety measures and space measures, I'm going to round it up to 1.31. And the y-intercept is 0.1017. Luckily, I'm going to keep it the same and making it 0.10. And so the equation with numbers should look a little something like this. Y equals 1.3x plus 0.1. And of course, in this simulation, I was asked to translate the equation into a much more complex one. Final velocity squared equals initial velocity squared plus 2a delta x. And of course, for me, it was a lot harder to find the numbers. So anyways, if you check your graphs, you should take the number that is your final velocity. In this case, I have 1.01 and square it. Then you should take the number that is your initial velocity and square that as well. You have to add that with 2 times the position. In this case, it's 2.99, and 1.31. You should multiply by that as well, because the delta would also represent the slope. And the formula should kind of look something like this. Sorry if this is all inaccurate or messy, but I didn't have much space to write on, and sorry if I'm inaccurate because physics is not my strong forte. So, thanks for listening.